Hello everyone, my name is Chiranjit Roy. I am the National Manager for Projects and Processing in Saint-Gobain India Private Limited. Today I am going to take you through the processing standards and the checks. We will be discussing on what are the EN norms for different processing standards and what are the checks carried out for doing different processing. So, the agenda of today's presentation is processing on glass standards and checks. We will be covering fully tempered glasses, then second we will be covering heat strengthened glasses, then we will be covering insulated glasses, and then we will be covering that laminated glasses. The tempered glass standard in European norms is EN 12150. So, first test what we are doing is the fragmentation test. So, for that the standard specification of the sample to be tested is 360 by 1100. So, along with every lot we need to set one glass for testing, and this is a destruction test, and this test is called fragmentation test. So, what we have to do is we have to break the glass at the center of 1100 mm sizes. So, from the center you have to come at a 13 millimeter distance, and then you have to break the glass with the help of a small tool. For the fragmentation test, you have to break the glass at the center, as I said in the earlier slide, and you can see from the point of breakage you have to exclude the area of around 100 mm from the center, and from the edges you can reduce 25 millimeter all across the thing, and you can count by putting a mask at in the dimension of 50 mm by 50 mm plus minus 1 mm, and you have to count the number of particles. In EN says from 3 millimeter to 12 millimeter the minimum particle count should be 40, and for all other glass thicknesses from 15 to 25 it should be minimum 30. Also EN also says about the dimensional tolerances of the glasses. So, you can see the chart depending on the thickness. If the thickness is less than 8 millimeter, and if the dimension of the glass is less than 2 meter, the thickness tolerance should be plus or minus, the dimensional tolerance should be plus or minus 2 millimeter. So, EN also says about the dimensional tolerances for any glass. So, there are standards, you can see this thickness tolerance, dimensional tolerances. If the thickness is less than or equal to 8 millimeter, for a glass of length or weight 2 meter, the dimensional tolerances plus or minus 2 millimeter is possible, is allowable. When the dimension thickness goes more than 8 millimeter, the same for the same 2 meter or less length, the dimensional tolerance of 3 millimeter is also possible. Similarly, for greater than 2 meter and less than 3 meter, dimensional tolerances of plus or minus 3 millimeter for a thickness of 8 millimeter or less, and for a more than 8 millimeter thickness the dimensional tolerance of 4 millimeters is acceptable. Similarly, for greater than 3 meter length or width, for a glass of 8 millimeter or less, the dimensional tolerance of 4 millimeter plus or minus 4 millimeter is acceptable. For a glass of more than 8 millimeter thickness, dimension tolerances of plus or minus 5 millimeter is acceptable. Similarly, you can see the table showing the deviation for diagonals also. So, in this slide I am going to discuss about the optical distortion. There are three kinds of optical distortion. One is the overall bow, which is the overall bend in the glass. Second kind of optical distortion is the roller wave distortion, and the third is the edge lift. So, EN says the norms for overall bow and roller waves. For an uncoated glass or a normal clear glass or a tinted glass, the overall bow as per EN is acceptable is 3 millimeter for a meter distance. That means, if the glass length is 1 meter, a bend of 3 millimeter is acceptable. For the other coated glasses or ceramic fluted glasses, the bend of 4 millimeter is acceptable. So, you can see that on the right hand side the roller wave is also mentioned. For a clear glass, it says 0.3 millimeter for 300 millimeter distance is acceptable. For a coated glass or a ceramic fluted glasses, 0.5 millimeter of roller wave is acceptable for every 300 millimeter distance. For edge lift, how do you measure edge lift? The glass shall be placed in a flat support with the edge lift overhanging the edge of the support between 50 millimeter to 100 millimeter. The gap between the ruler and the glass is measured using a feeler gauge, and Ian says for a uncoated glasses thickness of 3 millimeter, the maximum value of that edge lift is 0.5 millimeter. Similarly, for 4 to 5 millimeter thickness it is 0.4, and for 6 to 25 millimeter glasses it is 0.3. For other glasses like coated and all, it is acceptable up to a 0.5 value. Next we come to that heat strengthening glasses standards. The EN standard for this is EN 1863. So, the dimension and tolerances are similar to tempering, what we have discussed in the earlier slides. Similarly, for heat strengthened glasses also, the overall bow and roller wave is same like your tempered glasses, which you have discussed in previous slides. The edge lift also similar to tempered glasses. The fragmentation test for a heat strengthened glass is similar to tempered glass. The dimension of the sample is same like 360 by 1100, but in this case we have to take 5 samples and we have to break in the same position like fully tempered glasses, and each test specimen shall be inspected for fragmentation pattern, and an area of radius 100 millimeter center to the impact point and the border of 25 millimeter round the edge of the test specimen shall be excluded from the test. The examination shall be completed within 5 minutes of fracturing the glasses. Each fragment shall be assessed as follows. At least one edge of the fragment shall reach the excluded area as shown in that photograph. Where no edge or fragment reaches the excluded area, either an island or a particle is produced. What is an island? Island is an area of size more than 100 millimeter square, whereas a particle is an area of size less than 100 millimeter square. The number of island fragments shall be counted and each island shall be weighted. The particle shall be collected and weighted. At least 4 of the 5 specimen tested should meet the following requirements to qualify as a heat strengthened glasses. Each test specimen shall have no more than 2 island fragments, shall not have any island fragments with an area or mass equivalent to exceeding 100 millimeter square, and shall not have areas or mass equivalent of particles exceeding 5000 millimeter square. If only one of the 5 specimen fails to meet the requirements, then it shall match the below specimen to qualify as heat strengthened glass. It shall have no more than 3 island fragments, and the area or mass equivalent of islands and particle shall not exceed 50,000 millimeter square. Now, we will be going through insulated glass standards. So, insulated glasses, it says EN 1279. So, it says some thickness tolerances for the insulated glasses. If both the glasses are annealed and there is a air gap and the thickness tolerances is plus or minus 1 millimeter is acceptable. If one of the pane is annealed and another glass pane is toughened or heat strengthened, there is a dimensional tolerance, thickness tolerances of 1.5 millimeter is acceptable. Similarly, for the other combination it is mentioned in the table. Now, test for insulated glasses. The first test what we do is a desiccant test. In that procedure is you have to take 50 milliliter of water in a test tube or beaker, insert a thermometer ranging from 0 to 100 degrees centigrade in the test tube or beaker, measure the temperature, then take 50 grams of desiccant in a separate test tube or a beaker and add that 50 ml of water on the top of it. You have to check the initially what is the temperature of water, and after adding that water on that desiccant beaker, you have to measure the temperature after 1 minute, and you should see the rise of temperature should be more than 32 degrees centigrade. If it is more than 32 degrees centigrade rise in temperature is there, then it is the desiccant is good enough for using in a aluminum spacer. The second test what we do is the shore hardness test for silicon. For that you need to have a shore hardness tester. This shore hardness you have to check on the secondary sealant like silicon or polysulfide, whichever you are using in a insulated glass unit, and this you should check after 24 hours of applying the silicon. For silicon, the range of this shore hardness is from 35 to 60. The next test is pot light test. For this we have to take a small container and fill half with the sealant which is to be tested. You can place a stick or a pencil in the sealant as shown in the figure and note the time in record books. So, every 5 to 10 minutes pull on the stick as shown in the figure. If the sealant does not tear itself cohesively when the stick is pulled out, the sealant has not snapped. The time at which the sealant tears cohesively when the stick is pulled out, the sealant is snapped. The snap time will vary depending on the atmospheric condition, temperature, humidity and the individual doing the test. A snap time varying more than 45 minutes from what is expected may indicate that the equipment or the sealant is having problem. So, you have to retest it. Next test we call it a butterfly test. Normally it is to check the homogeneity in a mixing of silicon. So, you have to put silicon in a paper and then you have to fold the paper and immediately you have to open the paper again. So, you can see in your in the table there are figure 3 and figure 4. One you can see complete black and the figure 4 you can see there is a white patches are there. So, if figure 3 appears after the when you open the paper, then your mixing is proper. The figure 4 shows there is a white patches, that means the mixing homogeneity is not there. So, you have to remix it again. Now, we will cover the laminated glasses. What are the tests we are doing for laminated glasses? The standard for laminated glass in EN is 12543. The first test is high temperature test. The purpose is to check whether the laminated unit can withstand exposure to high temperature over an extended period of time. The changes in properties are judged by the occurrence of bubbles, delamination or cloudiness. For this test, the sample size should not be smaller than 300 by 100 ml. It should be plus 0 or minus 2 degrees centigrade. To remove the risk for thermal breakage in boiling water, test sample should be placed in water at 60 degrees centigrade for 10 minutes before transferring to the water at 100 degrees centigrade. How do you test it? For each test we take 3 specimens, procedure A in a oven and procedure B in a boiling water. In procedure A in oven, heat 3 specimens to a temperature of 100 degrees, maintain the test temperature for 16 hours. Take the specimens out and allow them to cool the room temperature and naturally keeping them vertically. For the boiling water, heat the 3 specimen to a temperature of 100 degrees. First, as I told earlier, we have to keep it at 60 degrees centigrade, then you have to transfer it for 200 degrees centigrade water. Maintain the test temperature for 2 hours. Similarly, you take the specimen out, allow them to cool in a room temperature naturally, keeping them vertically. After that, we do assessment when the temperature goes down to 30 degrees centigrade. Inspect the samples at a distance between 300 to 500 millimeter in front of a white diffuse background. Note, bubbles, delamination, haze, cloudiness indicates faults, but discoloration does not. Disregard all faults within 50 millimeter of the original edge and 20 millimeter from the cut edge. Individual bubbles in the immediate vicinity of inlaid wires are permissible. Disregard a test specimen showing cracks and perform test on a new test specimen in its places. This is what high temperature test says. The next test is a bake test. So, as mentioned in EN 12543, only bubbles, delamination or cloudiness are taken into account. A defect at a distance lower than 15 millimeter from the original edge or lower than 20 millimeter from the cut edge is not taken into account. So, after 1 hour at 145 degrees centigrade, if no bubble appears, it is okay. If bubble appears in the full face, it is okay except if the bubbles are countable. If bubble appears close to the edge, it is said to be okay. So, your whatever you are laminating is okay. Next test for laminated glasses is humidity test. The purpose is to check whether the laminated unit can withstand exposure to humidity over an extended period of time. This change in properties are judged by the occurrence of bubbles, delamination, haze and cloudiness. The sample size should not be smaller than 300 by 100 millimeter. This is further divided into 2 categories: test with condensation and test without condensation. Humidity test. Humidity test with condensation. So, we need to keep 3 samples vertically closed in a container for 2 weeks and we have to maintain at a temperature of 50 degree plus 5 degree centigrade. The conditions for test with condensation is about 100% humidity and lead to water condensing on the test specimen. For the humidity test without condensation, we have to keep 3 samples vertically up in a climatic chamber for 2 weeks. We have to maintain a temperature of 50 degree plus 5 degrees and relative humidity of 80 plus or minus 5 degrees centigrade. So, for both the cases we have to do the inspection from similarly at a distance of 300 mm to 500 millimeter against a white diffuse background. Bubbles, delamination, haze and cloudiness indicates faults. So, we have to disregard all faults within 15 millimeter from the original edge and 20 millimeter from the cut edge and 10 millimeter from any crack. Individual bubbles in the immediate vicinity of the inlaid wires are permissible.